Okay, ratios and proportions is what we are looking at today. This is an important topic because it has several applications in real life. So we're going to look at ratios first. What are ratios? Then we'll go to look at proportions, and then we're going to look at under proportion those which attempt to be direct proportions and those which attempt to be inverse proportion. So that's what we're going to look at the end of this particular session. So what can be the definition of ratios? Okay, in many textbooks or literature, you find the ratio being described as a comparison of two numbers or quantities. So it shows a relationship between two numbers. That's what a ratio is. For instance, you can talk about a ratio of boys to girls in a class being 2:3. Okay, so that's what it is, just as an example. And then, as I've already insisted or emphasized, the importance of ratios lies in the fact that it is used in everyday life, business and science. So it is quite an important topic to learn. So how do we write ratios? Okay, ratios can be written in basically three formats. As a fraction, like we have here 2/3 or 2:3, or you can use a colon in the second point. That's how you can write the same ratio, or you can explain it using words and say 2:3. All these are representing one and the same thing. So that's how you write ratios. Now, ratios normally are required to be simplified. So how do we simplify ratios? Ratios can be simplified by dividing both parts by their greatest common factor. And what do we call a factor in mathematics? A factor is a number multiplied by another number. That is a factor. So when you look at this example, 6:8, here 6:8, what are the factors involved? You can look at it in this manner. Let me just show you this particular one. Okay, I insert just to demonstrate this one. So you have 6:8. So you write it in this manner. It is 6:8. I think it is 6:8. Correct? 6:8. 6:8. Like that. Let me make it bigger so that you can see. Okay, so now when you look at this, you can talk about the factors on the left. You have 2 multiplied by 3. 2 multiplied by 3 is 2. On the other side, it can be 2 multiplied by 4. Okay, that's 1. Or you can also have 1. May I start with maybe 1 multiplied by 6 is the same as 2. This one is 1 multiplied by 8. Okay, that's how you can solve this, but that's how you can state this particular ratio in terms of factors. So we find on this side is 1 times 6, which is 6. On this side also there is 2 times 3, which is still 6. The other side is 1 times 8, which is 8, 2 times 4, which is 8. Now we are talking about what is the common factor on both sides. What is the highest common factor on both sides? 1 and 1 is a factor here, but it's not the highest common factor. So look at 6. 6 is the highest common factor on the left side, but there is no 6 on the side which calls for 8. So it's not a common factor. Then we look at the other side. We have 2, and it's also common this side is 2. Okay, we don't have 4 on the left, but we have 4 on the right. So we can settle for the highest common factor is 2, which is found this side, again 2 this found. So that's the highest common factor. So when we go back to this expression, we find that we can simplify these two figures by dividing both by highest common factor, which is 2. So divide 6 by 2, you end up having 3. Divide 8 by 2, you end up having 4. So that's how you simplify this particular ratio. Okay, so that's what I wanted to show you. Then we also have what we call equivalent ratios. Equivalent ratios. So we say that two ratios are equivalent if they represent the same comparison. An example I've given here is two ratios, 2:3 and 4:6. These represent equivalent or the same comparison. This represents the same comparison because this ratio on the right side can be actually be divided by the common factor of this to simplify to 2:3. So they are representing the same. Okay, they have the same comparison. So because they both simplify to 2:3, so they are equivalent ratios in short. Okay, so that's what we have there. And then let me look at now start looking at proportions. Okay, what is a proportion? A proportion can be given as an equation stating two ratios are equal. Okay, so it's a mathematical statement showing that two ratios are equal. For instance, we fall back on the same 2:3, which is equal to 4:6, because 4:6 can be simplified to 2:3, so they are equal. Okay, these are proportions. Okay, a proportion is an equation stating that two ratios are equal. So that's what we have. Now let's look at some of the problems that are solved in proportions. Okay, to solve proportions, normally you need to cross multiply and then divide. To solve proportions, you normally need to cross multiply and then divide. So for instance, we have solve for x in the proportion 2:3, which is equal to x over 12. Okay, 2/3 is equal to x over 12. These are proportions because according to our definitions, we said that a proportion is a mathematical statement, okay, which shows relationship of a number to another, okay, being shown as given here. And if I may take you back to what we started with, we did say a proportion is an equation stating two ratios are equal. So that's what we came up with. So we are going to start looking at that and solve them seriously. Okay, so here we are. So if this is the example that we are given, we want to find or determine what x is supposed to be. So in this particular case, we can cross multiply. In this case, we're going to have 2 multiplied by 2 over 3 equal to x over 12. So meaning that you have 2 times 12 multiplied equal to 3 times x. This as arithmetic is representing a multiplication. So then you solve for x, because this one will be 24 is equal to 3x. What is x? You divide both sides by 3. You are going to get x is equal to 8, and you solve for x in that way. Okay, so now we look at the next. How do you use proportions in the real world? So I want to show you how do we use proportion in the real world. So by way of an example or examples, the proportions can be used in many ways in life. Okay, for instance, if the example given here says if it takes 4 hours to paint a house, how many hours will it take 3 houses? How many will it take 3 houses? How many hours would it take for 3 houses? Okay, so you relate this. You look at what is the situation here. We set up a proportion. One house would take 4 hours. Okay, one house would take 4 hours. What of 3 houses? How many hours will it take? So that's what we have here. So 1 over 4 is equal to 3 over x. Okay, so we cross multiply. Okay, we're going to have x is equal to x times 1 and then 4 times 3. So x times 1 will still be x, and 3 times 4 will be 12. So x is solved as 12. So it will take 12 hours to 12 hours to paint 3 houses. To take 12 hours to paint 3 houses. Since one house it takes 4 hours, then 3 houses will take 4 times 3 hours. That is 12 hours. Okay. Now with that, we notice that we can look at these particular problems in 2 forms. We can look at these particular problems in 2 forms. We have the direct proportion and indirect proportion. How do we know that? We look at the variables we are trying to measure. If the variables move in the same direction, then it means that that is the direct proportion problem. What do we mean by moving in the same direction? If one variable is increasing, the other variable should also be increasing. If the other variable is reducing, the other one should also be reducing. If you observe such, then it means that they are moving in the same direction, and that is a direct proportion relationship. That's the direct proportion relationship. Okay, so let's look at this once more. Okay, 4 hours to paint a house. Okay, and then what of 3 hours? 3 houses. Okay, so when it takes 4 hours to paint a house, and you want to paint 3 houses, definitely the relationship here you expect is, since you are painting 3 times as many houses, you expect more time to be used. So that is an example of direct proportion. that is an example of direct proportion, because if the more houses you paint, the more hours you use. So the one variable increases, the other variable is expected to also increase. Then it shows that that is a direct proportion problem. So that's what you should understand. Okay, then we look at the next one. Okay, tells you a car travels 300 miles in 5 hours. A car travels 300 miles in 5 hours. How far will it travel in 8 hours? Okay, so again, when you see this, if the hours are increasing, you expect the miles covered to have increased. So again, this is a problem which is direct proportion problem. So it's a direct proportion problem. So with that, then you can say let D be the distance the car will travel in 8 hours. The distance is direct proportion to time, as I've already explained. So we can set up a proportion in this way. Okay, 300 miles 5 hours by 5 hours, and we don't know how many miles divided by 8 hours. So that is 300 miles takes 5 hours, and D, which we don't know, would take 8 hours. So we want to solve for D. We want to solve for D. So let me just show you this. We can have in this regard, let me just do a simple calculation for that, which is just to emphasize what I've done there. So we are saying in this regard 300 miles, 300 miles, bigger, 300 miles would take 5 hours. 5 hours. Okay. What of D hours? D miles, how many hours will it take? How many hours will it take? We have told 8 hours. So we want to find out these 8 hours, how much distance will be covered. So you can say small letter D, small letter D, how many miles will be covered. Okay, how many miles will be covered. So you cross multiply, that's what you're seeing here, 300 times 8 hours, so meaning you are cross multiplying 300 times 8 hours, which is equal to D times 5 hours. That's what you are seeing here. Okay, so then you have 5D is equal to 2,400. Then divide 2,400 by 5, you are going to end up having 480 miles. So that is how you get this one, 480 miles. So that's how you get that one. So that's some of the examples which you can look at when you are using direct proportion. Okay, let's look at a problem with inverse proportion. Inverse proportion. For inverse proportion, it simply means one variable, as it increases, the other variable is supposed to reduce or be reducing. Or if one variable reduces, the alternative variable should be increasing. So then when you see that is a situation, then just know that that is an inverse proportion. Okay? Okay? So there is an inverse relationship. There is an inverse relationship. So let's look at how we sort out this simple problem on inverse proportion. So we have here problem number 1. If 12 workers can build a wall in 6 hours, how long will it take 18 workers to build the same wall? So by implication, if we have more workers, we expect them to take less time. If we have more workers, we expect them to take less time. So the number of workers, if it grows, you expect the number of hours to be taken to reduce. So they are moving in the opposite direction. That is an inverse proportion problem. So how do we sort out that inverse proportion problem? So that's what we're going to show you. Let H be hours needed for 18 workers. And I've said that we know that the time needed is inverse proportion, as I've already explained, with the number of workers. So we can set the proportion as such. So 12 workers times 6 hours. The 18 workers times the hours we want to know. We cross multiply. When you cross multiply, you have 6 times 12 and equal to 18 times H. So solve for H, we end up having 4 hours. Indeed, when the number of workers are increasing to do the same task, we expect them to take less time. So from 6 hours, it drops to 4 hours, because that is an inverse proportion problem. Okay, that's an inverse proportion problem. Let's look at another example to help us understand this. We have problem number 2. We have a machine can produce 200 widgets in 10 minutes. How many widgets can be produced in 5 minutes? Okay, in 5 minutes. So definitely when you reduce the time, okay, when you reduce the time, in this particular case, a machine produced 200 widgets in 10 minutes. How many widgets can be produced in 5 minutes? So what will happen in this particular case? Less time will be involved in this particular case. So what do you expect? What would you expect? How many widgets can produce in 5 minutes at the same rate? Okay, so that's what we are going to look at. So in this particular regard, we can say let W be the number of widgets produced in 5 minutes, and the number of widgets produced is inversely proportional to the time. Okay, so we can set up proportion 200 widgets to 10 minutes, and the number of widgets we want to 5 minutes. So 10 times W is equal to 200 times 5. So for widgets, we have going to have remain with 100 widgets. 100 widgets. Okay. Are we together? So that's what it is. Okay, so these are some of the problems we have looked at. So what can we say about this kind of a problem? Okay, these the problems show to us that the application of direct and inverse proportion in real life scenarios is actually real. Okay, the direct proportion, you can see, involves increasing or decreasing in the same direction, while inverse proportion involves one quantity increasing and the other decreases, and vice versa. So that's what we have seen. So what can we learn about that? We can learn a number of things. Take home is that ratios compare two quantities. That's what you have seen. And then proportions are equations stating two ratios are equal. Then also, thirdly, I want you to remember that proportion can be solved using cross multiplication. So that is what we are supposed to know under ratios and proportion. That's what we need to know under ratios and proportion. Any clarification? Any clarification? Are we clear on this one?
Sir.
You're clear?
Is it always that ratios always have the same what numbers? Same and color different?
Same numbers in terms of what?
That first example on the first slide that you had given me.
Okay, I just deliberately use the same number. It doesn't necessarily mean that those are the numbers which are going to be there all the time. You can compare, you can have any numbers in a relationship. You can relate any two numbers in that manner and form a ratio. Okay, as I showed you, a ratio can be expressed in form of a fraction, as we saw. Is that okay? So meaning that you have a numerator and a denominator. Okay, there is a relationship. Okay, so that's what the ratio is. So it's not necessarily that you are supposed to have these same numbers there. No. Are we together?
Okay.
Okay, fine. Any other question?
No, that's all.
Okay, so I leave you at that so that you go through this. I'll just help you by putting this on my channel, then just watch several times and follow my explanation. Are we together?
No.
Okay.
Yes, sir.
Great. No.
You said Matthew is Lioba?
Michael Mwansa Lioba. Michael Mwansa Lioba. Is that okay?
Yes, sir.
Okay, bye. Good night.
Okay.